So, as we have stated over and over and over, the vertex is the most important point of any parabola, right? And the vertex, how do we find it? With the vertex formula, x equals negative b over 2 times a. Now, you guys have seen me write this formula over and over and over. You guys have also seen me write the word vertex and write a coordinate, right? Because the vertex is the most important point. It's a location. It's an x value and a y value. And whenever I write this formula, I always do this. I always write equals and I replace the b and the a with parentheses. And I know a lot of us students are not doing that, right? Please do that. That'll prevent you from making mistakes because it's really easy to simply plug in your b value of 4 and your a value of negative 2 right in there and right in there. So we're going to have a b value of 4 and an a value of negative 2. And that will give us x equals negative 4 over 2 times negative 2. That's a negative 4. And a negative 4 over negative 4, that's a positive 1. So we just found that the x value of the vertex is positive 1. So the x value of the vertex is positive 1. Anytime you have an x and you want a y, all you have to do is plug it in. So where are we going to plug in this 1 at? We're going to plug it in to the x values of the original equation. So I'm going to replace, you know what, there's a typo here. It should have said y equals, it says find the vertex of your equals. It should be y equals, I apologize. So I'm going to replace the x values with parentheses. Y equals, it reads negative 2x squared, negative 2x squared, plus 4x, and then minus 3 at the very end. So we put a minus 3 at the very end. And then we, of course, substitute the x value of 1 right in there. And then you could type all of this into a calculator carefully, because it has to be exactly like that in order for the calculator to compute this correctly. Or you could use PEMDAS and begin with the exponents. 1 times 1 is 1, but you still need to multiply it by that negative 2. So times negative 2, that'll give you a negative 2 as the first term. And then right here, 4 times 1 is 4. So you're going to have a plus 4 as the middle term. And then over here, the minus 3 comes down, minus 3. I shouldn't even be calling those terms as a middle number, I guess. Anyway, from left to right, you owe 2, you have 4. You're going to have 2, and then subtract 3, you're going to owe 1, right? So we just found that the y value equals negative 1. So the y value equals negative 1. What does that mean? The y value of the vertex equals negative 1. So we found the vertex 1 comma negative 1. Now, I hope you guys know how to do that, how to calculate that correctly. There's so many other things that I could ask you using this information of the vertex. Like, for example, if I said, what is the axis of symmetry equation? Well, the axis of symmetry equation will simply be x equals the x value of your vertex, okay? So you could get that answer if you know your vertex. Not only that, if you know your vertex and you know that it opens down, then you could also state the range of your parabola, okay? Even though you don't see the parabola, you know it opens down because the a value is negative. Now, what does that mean? If it opens down, think about that like just a sketch. If your parabola opens down, like let's actually plot this point, 1, negative 1, the vertex, the most important point is at 1 on the x and negative 1 on the y. There's my most important point, and I know it opens down because the a value is negative, right? So when I think of the range, I could actually state the range if I know the vertex and I understand that the a value is negative. Because the a value is negative, you could start writing the vertex y is less than or equal to, because opening down, it's going to be less than or equal to a certain value, the y value of your vertex. And the y value of your vertex is negative 1. So y is less than or equal to negative 1. So we were able to state many things knowing this vertex. The axis of symmetry is 1 and the range is the other. The axis of symmetry comes from the x value of the vertex. The range comes from the y value of the vertex, and also knowing if it opens up or down. Does that kind of clear things up for some of us? I hope so. Makes it a little more understandable. Let's move on. if I ask you for the axis of symmetry and I give you the graph, man, that's like free points right there, because the axis of symmetry is the vertical line that passes right through the vertex. And we said that the axis of symmetry is the equation x equals the x value of your vertex. Bless you. And obviously, it crosses at the x value of -2. That's the, like if I were to name the vertex, what is a vertex? It's the location -2, 5. But the axis of symmetry is x equals the x value of your vertex. So that's what you would type in, x equals -2. That's the axis of symmetry equation of that parabola that opens down, that has a vertex -2, 5. Obviously, it's a little more complicated if I ask for the axis of symmetry and I don't show you the parabola, because right there you have to actually find the vertex x value, because the axis of symmetry will be x equals the x value of vertex. That's what we have on the board. Those are the notes. The axis of symmetry equation will be x equals the x value of your vertex. So just like always, if you wanted to find the vertex, which is an x value and a y value, you begin with the vertex formula, x equals -b over 2 times a. And once again, whenever I use this formula, I always do this, negative parenthesis over 2 times parenthesis, then identify the a value, the b value, and the c value, which we don't care about the c because it's not in the formula. Simply plug in 16 right there and 2 right there. So what do we have as the x value? We have a -16 up on top. 2 times 2 is 4 on the bottom. So -16 divided by 4 is -4. And that is the x value of our vertex, -4. Now, if you wanted to find the y, you would plug in the -4 into the x's and do the math, do all this math, and it'll give you the answer to y, and you'd have your y value of your vertex. However, if you did that, that'd be a waste of time. Why? Because they're not asking for the vertex, they're asking for the axis of symmetry equation. And we should know by now that the axis of symmetry equation will always be x equals the x value of your vertex. And we already know the x value of the vertex. That's what the formula gives us, the x value of the vertex. So all we need to do is type in x equals -4. That's your answer to the equation of the axis of symmetry. All right, so we have these guys right here. 2 separate questions, super easy. The parabola y equals x squared minus 4x plus 5 will open up or down? What do you guys think? Open up or down? Open up, absolutely, not down, right? Why does it open up? Because the a value is positive. Super easy. So whenever the a value is positive, it's going to open up. Whenever the a value, that's when a is positive. If a is negative, then it's going to open down. It's kind of like if you're positive, you have the parabola opening up on a smiley face. If a is negative, you're sad, the parabola is opening down on a happy face, right? Anyway, knowing that the a value causes it to open up or down, if it's positive, it opens up. If it's negative, it opens down. Then you should be able to conclude if you have a maximum vertex value or a minimum vertex value. So on this one right here, do we have a maximum or minimum vertex value? Minimum. Why? Because it's positive, which means that it opens up, which means that the vertex is down here and there is no lower point than that. So it's definitely a minimum, not a maximum. Okay. So again, if it opens up, that's a minimum value. It's going down, 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 reaches the lowest point, goes back up, right? Going down, 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 reaches the lowest point, that's a minimum, then it comes back up. But if it were a value being negative, it'd be going up, 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 up until it reaches the highest maximum value, then it goes back down. I hope we understand that. And then stating the range, well, I'll tell you what, stating the range when you have a graph is really easy, because the range, after all, are your y values of the actual graph. So does this parabola exist at -2? No, it goes down, 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 down to that lowest point, right? That lowest point. What is that lowest point in terms of the y values? Is that lowest point 3? Is it 5? Is it 1? Is it -1? 0? What do you guys think? That's 1, right? The lowest point is 1, okay? So remember, your range values are your y values. Range are your y values, okay? And the y values, the y-axis is up and down. So here's a y value of 0. Here's a y value of -1, -2. Here's +1, +2, 3. Does a parabola exist at 5? Heck yeah, it's right on 5. Does it exist at 6? Yes, and it goes up forever. So it does exist from the value of 1 and above. So that's why y is greater than or equal to 1. Okay. Let me also say this, that the range comes from the vertex, because the vertex is the lowest point. That vertex is the coordinate 2, 1. And the range will come from y being greater than or equal to that y value right there of the vertex. Okay, so y is greater than or equal to y, that same exact y value of the vertex. So graphically, it's easy, seeing that the parabola exists at the y value of 1 and above. But if you look at this algebraically, it might be a little tougher because you don't see it. So in order for us to state the range, we need the y value of the vertex. In other words, we need the vertex to be able to determine where the range is at. But we could at least say that the a value, because it's positive, it's opening up, which means that the range has a y values that are greater than or equal to. I know that it's greater than or equal to because it's +1, which means that the parabola would open up. Okay, so it's going to be at a certain value and above. Anyway, so we need the vertex. So let's begin by doing the formula -b over 2 times a. Let me write that down. X equals -b over 2 times a. And when you use it, please use parentheses when you plug in the b and the a. The b value is -4. The a value is 1. So you have a 4 over 2, which gives you 2. So far, we have the vertex x value of 2, but we still need the y value. To do that, we're going to go back and replace the x's with parentheses and plug in that actual value of 2 right into those parentheses. So you put a 2 right there and a 2 right there. And if I do exponents first, which I'm supposed to, that'll give me a 4. And then right here I have a -4 times 2, that's going to be a -8. And then we have the +5 at the very end, +5 at the very end. So from left to right, 4 minus 8, that's -4. Bring down the +5, -4 plus 5, that is 1. And that is the y value, because it says y equals. We found the y value of the vertex. So let's go back over here. And the y value is +1. So now that we know the vertex, and now that we know that it opens up, we know that the range is y is greater than or equal to that y value of the vertex, +1. So that's a range, y is greater than or equal to 1. Let's get to some more entertaining questions. Actually graphing. So we have this quadratic trinomial equation. Right here, you need to find the vertex. Let's find that vertex. X equals -b over 2 times a. That's going to be negative parenthesis over 2 times parenthesis, where your b value is 8 and your a value is 1. 8 and 1. And when we do this math, on top we get a -8, on the bottom we get a +2, and of course -8 divided by +2 is a -4. That is the vertex x value of -4. Now we still need the y value. All you do is plug it in. Plug it into what? Plug in the -4 right into the x's with parentheses. So I'm going to rewrite this thing. Here it is. Y equals x squared plus 8x plus 17. And I put parentheses instead of x's because I know what x is. X is -4. Plug in the -4 right there and there. So -4 and -4. Then you do the math. You could type it all into the calculator. I recommend using your paper and pencil, PEMDAS. -4 times itself is a +16. 8 times -4 is -32. Bring down the +17. And then from left to right, 16 take away 32, that's -16 plus 17. That's going to give us 1. And what do we just find? That y equals 1. Now this is the y value of our vertex. So we found the x value, that was negative 4. We now found the y value by plugging in x, that's positive 1. So how do we graph this? We go to the xy plane on quizzes and put the most important point at negative 4, positive 1, and you leave it right there. And then you need more points. So you could use an input-output table. But I don't recommend that. I recommend using the pattern 1, 1, 2, 4, 3, 9. Now, what does that mean, 1, 1, 2, 4, 3, 9? These used to be coordinates on the original parent graph y equals x squared, but we're going to use these as patterns now from the vertex. So here's our vertex. We're going to go 1 over 1 up. 1 over 1 up. So we're going to put a dot right there. Then you go back to the vertex. And the next one is 2 over 4 up. 1, 2, 1, 2, 3, 4. Put a dot right there. And the last one's 3 over 9 up. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. You put a dot there. Now you need to map the points over to the other side. So let's do that. We're going to take this one that's 1 unit away from the axis of symmetry, 1 unit away from being right on top of the vertex, and go 1 unit this way to reflect it. And the next one, we're going to go 2 units over. So 2 units over would be right here. And the last one is 1, 2, 3 units over. So 1, 2, 3 units over. Hit submit. That'll be your parabola. Now, again, if you were doing this on paper, of course, you would draw your parabola. And not only that, you put arrows on it right there. And if you were drawing it, you'd probably also draw your axis of symmetry going right through it. But on quizzes, all you got to do is submit those dots right there, and that'll give you full credit. This is the type of question you're going to see on your quiz the day after tomorrow, right? So it says plot 5 points of the graph, and it gives you this quadratic trinomial equation. So anytime you have your parabola equation, you want to first start graphing it by finding the vertex. The vertex is a location. It's the most important point of a parabola. It's either the highest point or the lowest point, depending on if it opens up or down. The a value is negative, so it's opening down. This vertex location will be a maximum value. Anyway, if you forgot how to find the vertex, you could always read the board right there. On the success criteria, it says the vertex formula. You find the vertex by writing down your vertex formula, x equals negative b over 2 times a. And I always write this. Every time I explain it, I always write it down. And right after writing down the formula, I also write down equals, and then I replace the b with parentheses and the a with parentheses. I rewrite it, but instead of negative b over 2 times a, I put negative parentheses over 2 times parentheses. That way, you won't make a mistake when you plug in your b value of 12 and your a value of negative 1. And the c value of negative 38, you don't even need it. It's not in the formula. So we're plugging in the b value of 12 right there and the a value of negative 1 right there. And you end up with a negative 12 up on top. And on the bottom, you have 2 times negative 1, that's negative 2. So you really have a negative 12 divided by a negative 2. That gives you a positive 6. Now, what equals positive 6? X equals positive 6. So the vertex has both an x value and a y value. The x value is positive 6. You still need the y value. On any equation, doesn't matter if it's a parabola or if it's a linear equation, any equation, when you have the x and you want the y, you simply plug it in. So you plug in the 6 right here and right there into the x's. We already know x equals 6. Here are some x's. Let's put some 6's right there where the x's are at. So the safest way to do it is to rewrite it. Y equals negative x squared plus 12x minus 38. And we replace the x's with parentheses. That way you could easily plug in the 6 into those parentheses. And then you do the math. How do you do the math? Well, you could use a calculator. If you use a calculator, make sure you type it in carefully, exactly the way it is. Hit equal, and it'll tell you your y value. If you don't want to use a calculator, start with exponents. Now, this is a positive 6 squared. That is a 36. 6 times 6 is 36. Now, yes, it does have a negative sign that you're going to bring down. And then from there, you're going to multiply the 12 times 6. That's 72. And it is a positive 72. And of course, you could bring down the minus 38. Whoops, minus 38. And now it's just adding and subtracting from left to right. So when you go from left to right, you owe $36, but you have $72. You could pay them off and you'll actually have $36 left over. And you still have a minus 38, and 36 take away 38, the answer will be -2. If you have $36 and you owe 38, you owe $2. Anyway, this is the answer for y. Y equals -2. So the y value of what? The y value of the vertex equals -2. So -2 goes right there. This is the most important point, the vertex, 6, -2. So you go to 6 on the x, -2 on the y, and you put a dot right there. Whoops. And you're going to have to do that on quizzes. You plot that point. That's the most important point. Now, from there, you need more points. So you could go to like a input-output table, and you could plug in some numbers. Like, let's say you could plug in the number 0 if you wanted to. That would be the y-intercept, technically. To find the y-intercept, you set x equal to 0. And if you did plug in a 0 here and there, you'll get -36. No, -38, I'm sorry. So 0, -38 is a point on this parabola, but there's no way you could show 0 on the x and -38. It's way off the graph. So obviously, using an XY table is not the best option. What I would say is to use the pattern that I asked you to memorize. When your a value is 1 or -1, you could use a pattern 1, 1, 2, 4, 3, 9. Okay. Now you could modify this pattern according to your new value of -1, or you could just use this pattern, but remember that it's opening down, not up. So again, the pattern is 1 over and 1 down because it's opening down. And then you go back to the vertex and you go 2 over and 4 down. Then you go back to the vertex, 3 over and 9 down. And we are going down because the a value is negative. All right, anyway, so let's actually do that. From the vertex, you go 1 over, 1 down, and you put a dot right there. You go back to the vertex, you go 2 over and 1, 2, 3, 4 down, and you put a dot right there. And of course, there is an axis of symmetry equation. You're not going to be able to draw it on quizzes, but that's just the line that crosses right through the vertex. That's the vertical line. That's the equation x equals 6 in this case. X equals the x value of your vertex. But that line provides a reflection from one side to the other. So I could get a point and reflect it. You know how it's 1 unit away, go 1 unit this way and leave it right there. Take another point. This one goes 2 units away from the axis of symmetry, 2 units, and put it right there. And that's all that fits. If I tried the last point, 3, 9, or the last pattern, 3 over, 1, 2, 3, and 9 down, you're going to be off this graph. So that's why it says plot 5 points only. These are 1, 2, 3, 4, 5 points. Hit submit, and that'll be full credit right there. Of course, if it were on paper, you would actually draw your parabola going through these points with an arrow, and that's how you do it. Are we good? All right, let's take a look at one that the a value is not 1, okay? Right here, the a value is 2. So you're going to go through the same deal. The most important point is the vertex, which is a coordinate, an x value and a y value. To find that x value, we use a formula, -b over 2 times a. When you use the formula, please use parentheses, negative parentheses over 2 times parentheses. Then you could easily identify your b value of 8 and your a value of 2. B value is 8, a value is 2. So you really have a -8 divided by 2 times 2 is 4. -8 divided by 4, that's giving you x equals -2. Now this is the x value of your vertex, -2. Now you still need the y value, and anytime you have the x value and you need the y value, simply plug in your x value of -2 wherever there's x's at, and then you do the math. So you have y equals 2x squared plus 8x plus 7, and the x value is -2 that we're substituting right in there that we got from the vertex formula. And then after that, you could type it into your calculator, or you could use PEMDAS, the correct order of operations. Let's begin with exponents. -2 times -2 is a +4, but you still have the multiplication of 2 in front of it, so still multiply it by 2. You'll get 8 right there as that first number. And then the second number, +8 times -2, it's a -16. And at the very end, you have the +7 here, so bring that down, +7. Now it's just a question of adding and subtracting from left to right. If you have 8 and you owe 16, you're still going to owe 8 and bring down the plus 7. If you owe 8 and have 7, you're still going to owe 1. So your y value is -1. So the y value right here is -1. Now, at that point, we now have the most important point at that point, which is a vertex, which is a location -2 on the x, -1 on the y. So let's plot that point. -2 on the x, -1 on the y. We put a dot right there. Now from there, you need more points. And yes, you could go to an input-output table, but it's better to use your pattern 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3. Oh, that's ugly. Let me do 3, 9 in red so it could stand out. But the thing is, you could only use this pattern if your a value is 1. If your a value is 2, if your a is 2, you're going to have to multiply your outputs by that new a value of 2. Again, the pattern 1, 1, 2, 4, 3, 9 came from the original parent graph. These are the inputs, and these used to be the outputs. The 1, the 4, and the 9. You have to multiply the 1, the 4, and the 9 by the new a value. And it doesn't matter if it's the a value of 2, or the a value of 3, or the a value of 1/2. Whatever your a value is, you're going to multiply the 1 by that new a value, the 4 by that new a value, and the 9 by that new a value. So what do we have? 1 times 2 is 2, 4 times 2 is 8, and 9 times 2 is 18. So the new pattern is now 1 over from the vertex and then 2 up. And then you go back to the vertex and you go 2 over from the vertex and 8 up. And then you go back to the vertex, 3 over from the vertex, and 18 up. Now, you're probably not going to use all of them. It does say plot only 5 points, so we're probably not going to use the last one of 318. But anyway, we do, from the vertex, go 1 over, 2 up. So I want to get a point, go to the vertex, go 1 over and 2 up, and I want to leave it right there. I want to get another point, and then I want to go 2 over, 8 up. Okay, so from the vertex, 2 over and 8 up, that would be up here at 7 on the y-intercept. And then the last one, if you did try to go 3 over 18 up, it's not going to work because you go 1, 2, 3. I mean, it will work. But if you go 18 up, you're going to be way off this graph. So you're not going to be able to graph it. But it does exist. Anyway, we do know that the axis of symmetry line goes right through the vertex, which provides a reflection onto the other side. So this dot gets reflected over 1 unit. And this other dot gets reflected over 1, 2 units. So you go 1, 2 units, and you put it right there. And there is your parabola. If you hit submit, you'll get the right full credit right there. If it were on paper, you actually draw it and you put arrows on it. Ta-da. Now, like I've always said, you don't have to use the pattern or the modified pattern. You could have, if you wanted to, use like an input-output table, like a XY table. But the thing with that is sometimes when you plug in a number, like let's say you were to plug in 1, it's going to be off the graph, right? I could already see that it's going to be off the graph. But if you did plug in 1, 1 squared would be 1, 2 times 1 is 2, 8 times 1 is 8, 2 plus 8 is 10, 10 plus 7 is 17. So when I do plug in a 1, I get out a 17. So at that point, you'd be like, oh man, I kind of wasted time because 117, I can't even show it on the graph. So it's better to go with the pattern or the modified pattern from the vertex. Because if you're going from the vertex, you'll always be close to the vertex and you'll always be able to graph it. What the heck? Look at that one. The a value is 1/2. You guys know how you're going to change that pattern? You do? All right, great. Let me just walk you through the whole thing because it's fun. What's step 1? Find the vertex. How do I find the most important coordinate? With the formula. What's the formula? X equals -b over 2a. And like always, please rewrite it, but with parentheses instead of the b and the a. That way you don't make mistakes. So the b value is what? -4. The a value is 1/2. So the b value is -4. The a value is 1/2. And if you're freaking out right here, you could use a calculator, right? Just type in 2 parentheses, 1 over 2, close parenthesis, hit equal, and it'll give you the answer 1. So on the bottom, you have a 1, and up on top, the -4 becomes a +4. So that's really just 4, right? So the vertex x value is 4. You still need the y. All you have to do is plug it in. How do you do that safely? Just rewrite the entire equation, but instead of x's, put parentheses. Y equals 1/2 x squared minus 4x minus 1, and plug in that 4 right there and right there. You do the math, start with exponents first. 4 squared, that would be 16, but you still need to multiply it by the 1/2. So 16 times half, you could do that on the calculator if you want, that's just 8. And then 4 times 4, that's 16 with the minus sign in front, right? That minus sign just comes straight down. So you have 8 minus 16 minus 1 that also just came down. So from left to right, 8 take away 16, that's a -8, and -8 minus 1, that's a -9. So the y value equals -9. Y equals -9. Now we are talking about the y value on our vertex, +4, -9. So that's really easy to do, to graph. Once you know that vertex, go to +4 and -9 and put a dot right there. Now from that dot, you could use the pattern, but you have to modify the pattern, right? The pattern is 1, 1, 2, 4, 3, 9. However, you need to multiply the outputs by what? By 1/2, right? By the new a value. The new a value is 1/2. So you have to multiply 1 times 1/2. You have to multiply the 4 times 1/2 and the 9 times 1/2. And you could do it on the calculator. 1 times 1/2 is 1/2 or 0.5. 4 times half, that's 2. And 9 times half, that's 4.5. Half of $9 is $4.50. So your new pattern is from this vertex. From this vertex, instead of going 1 over 1 up, you're going to go 1 over and only halfway up. Okay, so keep that in mind. 1 over and only halfway up. And then you go back to the vertex 2 over 2 up, then back to the vertex 3 over and only 4.5 up. The problem is when you get a point on quizzes and you go 1 over and you try to go right there halfway, it's going to jump all the way here. It's not going to let you stay in the middle. So it's not going to let you plot that point. Okay, so that's a problem. So if it were on paper, yeah, you could put a dot right there, 1 over and then only halfway up. But on quizzes, you can't do that. So you need to go to a nice coordinate. So you go back to the vertex and you go to the next part of the pattern, 2 over 2 up. So you go 2 over 2 up, okay? And that you could plot 2 over 1, 2 up, and you put a dot right there. Now, of course, the axis of symmetry will allow you to map it over to the other side. So you will be able to take the point that's 2 units away and map it over 2 units away and put a dot right there. The problem is that if you try the last part of your pattern, 3 over and 4.5 up, if you went 1, 2, 3 over and 1, 2, 3, 4.5, you're going to be right there, and quizzes will not let you stop right there at the halfway point. It will not. So that's 1, 2, 3, 1, 2, 3, 4, 4.5. It won't let you put the dot right there. And even if you did put the dot right there, you'd map it over here, but again, quizzes doesn't let you do that. So we need another nice point, but there's nothing left on the pattern. Any ideas on how to get another nice point? I mean, we could go to an input-output table and plug in like the number 8 and see what output you get. Or what's a really easy coordinate to find on a parabola, especially in standard form? The y-intercept. Where do you think this parabola is going to cross the y-axis? Is there a way to do that? I hope we remember to find the y-intercept, you could set x equal to 0 and solve. Okay, so you're going to get the coordinate x being 0, and what would y be if your x is 0? That's really easy to do. You want to know what y is when x is 0? Plug in 0 where your x's are at and do the math. What do you get? When you plug in zeros right there, 0 squared 0, 1/2 times 0, 0, 4 times 0, 0, 0, take away 0, 0, 0 minus 1, -1. So the y-intercept is 0, -1, and that location is right here, 0, -1. So that is a nice point. That's what you put right there, and then you could map that over to the other side. So 1 unit, 2 units, 3 units, 4 units, 1, 2, 3, 4, and there is your, what happened, 1, 2, 3, 4, and there's your perfect parabola. Those 5 points that they asked you to plot 5 points. I just plotted them. That's the correct way to get full credit on this one. Of course, if it were on paper, you'd put a parabola, a U-shaped curve through all these points. with arrows on it, and we're done.